Yeah, children, a small discussion about radioactivity. Only summary, children. I am not going into depth. I will discuss all the topics so that you will understand. So, children, girls, what happens in the radioactivity is that all the elements, okay, there are almost 109 elements are there. Approximately different books will claim different, that is different issue. So, 82 is lead, atomic number 82 is lead. Atomic number 83 is bismuth. From bismuth onwards, remaining all elements show radioactivity. Then you will get doubts, sir, what is radioactivity first of all? Radioactivity means after 83, 84, 85, 86, all the elements, uranium, radium, neptunium, polonium, thorium, all these elements, they emit radioactive rays. Means alpha rays, beta rays, gamma rays, they keep on emitting. These elements, if you take uranium 92, 235 is there, 238 is there, okay, 235 is there, 238 is there, isotopes. They'll be emitting alpha, beta, and gamma rays. What for they will emit alpha, beta, and gamma rays? To attain stability. To attain stability. Yeah, you understand? To attain the stability. Normal elements, atoms, to attain stability, they will form molecules. Normal elements, to attain stability, they will form molecules by undergoing ionic bond or by covalent bond, by coordinate covalent bond or metallic bond or van der Waals bond or some other bond. But these elements above element atomic number 82 from 83 onwards, they emit radioactive rays, alpha, beta, gamma, continuously they will be emitting to attain stability. Will they attain stability, sir? You will get doubt. Yes, they will attain stability. How? I'll show. What is an alpha particle? Means alpha particle is helium, doubly ionized helium atom. Actually, helium plus 2. Actually, helium plus 2. Doubly ionized helium atom. Helium particle is alpha. Electron is beta particle, electron. And neutron is gamma particle. No charge, no mass. No charge, no mass. Neutron is gamma particle. Okay, children? Alpha means helium. Beta means electron. Gamma means neutron. No charge, no mass. Then how do they attain stability? I want to show you. That's why I wrote all this. How do they attain stability? Simple, children. I'll give an example. Small example I'll give, then I will go into detail. Okay, small example. Suppose, children, uranium is there. Uranium 92, 235 or 238, anything you get. When it emit one alpha particle, when it emit one alpha particle, means 2He4, it emits 92 minus 2, 90, 235 minus 4, 231. You will get thorium. Means uranium after emitting an alpha particle became thorium. Thorium again emits alpha particle. Thorium again emits an alpha particle, and thorium 90 minus 2, 88, 231 minus 4, 227 becomes radium. Becomes radium. Okay, means uranium became thorium, thorium became radium. Radium emits again an alpha particle. It will become 86, 88 will become 86 because 92 became 90, 90 became 88, 88 becomes 86, 227 will become 223, and some element. Again, it will emit one more alpha particle. Again, it will emit one more alpha particle, and 86 will become 84, 223 will become 219, it will become some other particle, and this will emit one more alpha particle, and it will become 82 and 215. This is your lead. This is your lead. So children, see, slowly by emitting alpha particle, alpha particle, alpha particle again and again, again and again, again and again, one or other day it is becoming lead. The lead means stable. Till lead, all are stable, children. After lead only, the 83 elements onwards, they emit alpha particles, beta particles, gamma particles to attain stability. Then you will get to, sir, correctly what you said, like alpha particle, alpha particle, alpha particle, alpha particle. If it emits in one day, today it will emit no, sir. Over no, you may ask. Not like that, children. I have shown for your understanding. It may emit alpha particle, it may emit beta particle, it may emit gamma particle, and every element has half-life, children. Radium 88, Okay, to become half of its original element, half of its original amount, it will take almost 2000 years, children. Every element will have half life. What is half life means? The time taken by the element to come become half of its original amount. If I take 10 grams, 5 grams radium will become after 2000 years after attaining stability. So in 1 day, 2 day after emitting the alpha particles, uranium won't become stable. Till it becomes stable, it keeps on emitting alpha, beta, gamma, permutations, combination, again and again, again and again, permutations and combinations will occur. And finally, one or other day, after thousands of years, it will become lead. Once it becomes stable, it won't emit any alpha, beta, gamma rays. Okay, children. So what is my intention of saying all these things is, first I want to say this: radioactive elements emit, it may emit alpha particle, it may emit beta particle, it may emit gamma particle, all of them to attain stability. All of them, they will attain, they will elements will liberate this particles to attain stability. Once they attain stability, they will stop emitting alpha, beta, gamma rays. Let them emit. So what is the problem, sir? You will ask. Let them emit means, children, alpha particle, beta particle, gamma particles are very dangerous, children. Very, very dangerous. If we expose to those particles, we may suffer from cancer and we may die also, we may get mutations also, anything can happen. They are very, very dangerous elements, children. Radium is there. Pure radium keeps on emitting. That's why it glows, children. Pure radium, if you see, it glows. Why it glows? Because it will be emitting alpha, beta, gamma rays. With bare hand, you should never touch radium. If you touch radium, we will get cancer. Madam Curie, she died because of working with radium only. She died because of cancer. She knows that she will die. In spite of that, she worked on it and she discovered all this radioactive waste. So, what is the thing is, why they emit all the elements after atomic number 82? Why they emit alpha, beta, gamma rays means to attain stability. To attain stability. When they emit alpha, beta, gamma radiations, they will liberate. Sometimes they also liberate large amounts of energy. Large amounts of energy. So this energy will be used for destructive purpose means destructive purpose, constructive purpose means constructive purpose. Okay, children. So what happens means, suppose one sample question I will say. After that, I will go to another topic. Sample question I will say: uranium 92 to 38 is there. You may get question like this. It will emit two alpha particles and three beta particles. What is the resulting element? Like this, you will get questions. Two alpha particle means after emitting one alpha particle, it will become 90 to 34. Element can be anything, no problem. After emitting one more alpha particle, 90 will become 88, 234 will become 230. Element may be anything, actually radium. After emitting one beta particle, atomic number will increase, 89 actinium, and mass number won't change. Again, after emitting one more beta particle, 89 will become 90, 230 will remain 230. Again, after emitting one more beta particle, children, one more beta particle, it will become 91, 230, 91. So it is becoming 91 element, children. 91, I think, plutonium, something. Okay, like this. The last question in exam. Uranium 92 to 38 is there. After emitting two alpha and three beta particles, a resulting element will have atomic number and mass number. What? Atomic number is 91, mass number is 230. How to remember? Slowly I will say listen. Whenever any element emits alpha particle, atomic number decreases by 2, mass number decreases by 4. Whenever any element emits beta particle, atomic number increases by 1, mass number does not change. If you can remember this, it's over. See, alpha particle means decrease, alpha particle means decrease, beta particle means increase, increase, increase. You should remember. Why it happens? Because here alpha particle means 2He4, no children. Okay, I will show you one small example. Uranium 92 to 38. If it emits one alpha particle, 2He4. 92 minus 2 is 90. 238 minus 4 is 230. That's what I'm saying from that time. 238 minus 4 is 234. Sorry. Okay, children. That's what I'm saying. Mass number decreases by 2 units. Sorry, atomic number decreases by 2 units. Mass number decreases by 4 units. No, okay. Okay. Suppose same element 92, 238 is there. It emits one beta particle. What is beta particle, children? Beta particle means minus 1 E0. Minus 1 E0. Beta particle means what minus 1 will give you 92? 93. And what minus 0 gives 238? 238 only. And elements remains minus 2. Okay. So when any element emits alpha particle, atomic number decreases by 2 units, mass number decreases by 4 units. And when any element emits beta particle, atomic number increases by 1 unit and mass number does not change. This you have to remember. Slowly you should read. Don't forget. If you forget this, many questions you will not be in a position to answer. Again, last time I'm saying, after this I won't say. When any element emits alpha particles, atomic number decreases by 2, mass number decreases by 4. When any element emits beta particle, atomic number increases by 1 unit, mass number does not change. Atomic number increases by 1 unit. Then you will assign gamma particles. What happens? If gamma particle element is empty, nothing will happen to atomic number and mass number because gamma particles don't have mass and charge. Okay, children. This is how it is happening. Now listen, children. So alpha, beta, and gamma rays, who is emitting radioactive? Why they are emitting to attain stability? In this process, for one of the famous reaction, nuclear fission reaction was discovered. Nuclear fission reaction. Do you know what is nuclear fission, children? Nuclear fission means a big element is taken and bombarded with a slow moving neutron, then this will breaks into krypton and barium by liberating 3 more neutrons and large amounts of energy. What you are saying, sir, we are not able to understand anything. You will say, I will know. Listen, you take uranium and hit with neutron. Okay, when hit with slow moving neutron, not fast moving. Normally, children, till now in normal chemistry, wherever we studied all the reactions basing on the electrons. But in nuclear physics, in the middle of the atom, nucleus will be there. No, that nucleus will break. Who will break that nucleus? Neutron. Why it will break? Because it has got tremendous amount of energy. So this neutron will go and hit the uranium. You will get 3 more neutrons. So large amounts of energy will be liberated whenever 3 neutrons, large amounts of energy. These 3 neutrons won't keep quiet, children. They will go and hit again this uranium only. 9 neutrons are liberated. These 9 neutrons won't keep quiet, children. Again, they will go and hit uranium. And 9 neutrons you are getting, no? These 9 neutrons will not keep quiet. They will go and hit again uranium. Then you will get 27 neutrons. 27 won't keep quiet, children. Again, they will go and hit uranium 81. They will go and hit again uranium 243. Like that, into 3, into 3, into 3 keeps on occurring there. And let it occur, no sir, no problem, you may think, but every time when neutron is released, large amounts of energy is released, children. Almost 1000 degrees centigrade energy is released. 40-50 degrees temperature in summer only we can't bear, children. Imagine 1000 degrees centigrade each time neutron is coming. So many neutrons again and again, again and again, again and again, means how much energy will be liberated, you imagine, children. This principle is used in making atom bombs, which was thrown on Hiroshima and Nagasaki during World War II. And the name of the atom bombs are Little Boy and Fat Man. Okay, children, this principle is only used. Nuclear fission, what they will do means they will take a uranium, slow moving neutron, it will hit, this neutron will liberate 3 neutrons, the 3 will go and hit again uranium, 9 will come, 9 will go and hit again uranium, continuously they keeps on occurring within 1 minute, 2 minutes, large amounts of energy, 243,000, means imagine, children, so much energy is liberated, and that all energy will become atom bomb. And within no time, entire area will get devastated depending upon the amount of uranium you are taking. Little uranium you take, small part. More uranium you take, more part. How much uranium you take, that much devastation you can create. This is fission, nuclear fission used in making atom bombs. And this reaction is called chain reaction. 1 is becoming 3, 3 is becoming 9, 9 is becoming 27, 27 is becoming 81, 81 is becoming 243, 243 is becoming 8, 9, 4, something you will get. This is called chain reaction. What is chain reaction? 1 is becoming 3, 3 is becoming 9. That is chain reaction. You might have seen that movie, no children, Tagore movie, Chiranjeevi will say, you help 3 of them, that 3 will help 3, 3 more 9, that 9 will help more 3, 3, 3, 27, that 27 will help 3, 3, 3, like that, a chain reaction, and all will be helping each other. You saw Chiranjeevi movie, Tagore or Stalin, I think, Stalin. Same way, children. Here also, same children, same. What is happening? An atom bomb, large amounts of energy will be liberated within no time. This much devastation will occur. This much devastation. This is destructive. No, sir, I want to use it constructive. Means constructive also you can use it, children, by making nuclear reactor. We can use it for constructive purpose also. You can generate electricity continuously without the use of coal and water. How? So, children, the same energy, children, same energy we can use in constructive way also, children. Constructive way, see, children. Uranium is hit with neutron. 3 neutrons are coming. 3 will become 9. 9 will become 27. 27 will become 81. Avoid that. When one neutron is hitting 3 neutrons, remove 2 neutrons. This one will go and hit uranium again. Again, you will get 3. Again, remove 2 neutrons. This one neutron will go and hit uranium. Again, 3 will come. Again, remove 2 neutrons. So, the amount of energy will be 1000 degrees only, and it will be under our control. Then you will ask, sir, how we will remove neutrons, sir, with our hand will remove? No, we should not remove, children. We will keep a control rod. Control rods are made up of a nuclear reactor. Barium or cadmium rods will be there, children. Using cadmium or barium rods, out of every 3 neutrons, 2 neutrons they will take, 1 neutron they will allow to go and hit uranium. Again, I'm saying, out of every 3 neutrons, 2 neutrons they will absorb, and one they will allow to go and hit the uranium. And the amount of energy which is liberated is under our control. Means it's not going out of control. One is becoming 3, 3, 9, 9, 10, 7, 27, 81, means it's out of control. One is on again one is becoming again one is becoming again one, means it is under our control. So this temperature is used in boiling the water. That boiling water converts into steam. Steam has capacity to rotate the turbines. Turbines are connected to generator, and generator produces current. Current we can produce in foreign countries, in most of the Russian countries, France, America, Japan. Their energy, electricity is produced by nuclear reactors, children, not like coal and water like in our country, like how thermal power station, hydropower stations, very less. More is from nuclear reactors, they will produce current. If you produce current like this, it is very cheap, you will get, children, and continuous you will get. But the only thing is potentially danger. If you are not taking proper control, all 3 are going and hitting uranium, means 3 will become 9 and will become 27. You lose the control and entire state will be devastated within no time. You should take proper care of the reactor, nuclear reactors. Then you will ask, sir, in our India we don't have nuclear reactors. I mean, sir, we have, children, nuclear reactors, small reactors are there only for laboratory research, not to produce current. If you produce also very small scale reactors. Okay, children, if you don't take proper care when big reactors get, children, it can cause a lot of devastation as it occurred in Russia in 1983, 1987, I think. Chernobyl incident occurred, children. Once nuclear reactor got blasted, and immediately they took proper precautions because it is Russia, they can do. But in India, that much technology is not there. It's very dangerous. If you do any mistake, it will become atom bomb. Reactor can become atom bomb. If you control atom bomb, it is a reactor. If you can't control reactor, it will become atom bomb. Everywhere, reaction is same. What is the reaction? Nuclear fission. What is nuclear fission? Again, I'm saying slowly. Fission means a big atom like uranium, when bombarded with slow-moving neutron, breaks up into two smaller atoms by liberating 3 neutrons and large amounts of energy. Large amounts of energy. Again, the 3 neutrons will hit uranium and will become 9 by liberating large amounts of energy. Again, that 9 will hit uranium and become 27 by liberating so much amount of energy. That energy, if we can't control, it will become atom bomb. If we can control, it will become reactor. How to control the number of neutrons produced? Out of every 3 neutrons, absorb 2 neutrons, one you allow to go and hit. How to absorb two neutrons? By putting cadmium or barium rods. Cadmium or barium rods are called as control rods. Okay, and the heat produced in the reactor is controlled by heavy water. Is controlled by heavy water or liquid sodium. What they will do, they will control the amount of heat. Moderator, they will slow down the neutrons. The heavy water means D2O, not heavy water means not normal water. Heavy water means D2O. D2O means deuterium oxide. Normal water means H2O, no? Heavy water means D2O. It acts as a moderator. What is a moderator? Moderator slows down the neutron, because if neutron go and hit uranium fast, it will not break, children. If it goes and hit slowly only, it will break, because it should go through the nucleus, then only it will break. This is fission, children. Now comes topic, what is fusion? Till now, whatever I discussed is fission. Fission means big one breaks into small, bigger is becoming small. Now, fusion. What is fusion? Smaller atoms like hydrogen atoms combine to form bigger atom like helium. Okay, children. Smaller hydrogen atoms combine to form helium by liberating large amounts of energy. Fusion reactions are occurring in the sun core, children. Sun's core, fusion reactions are occurring. Sun is liberating so much amount of energy all over the universe, which it is because of fusion reaction. Using the fusion reactions, hydrogen bomb is made. Using fusion reactions, hydrogen bomb is made. Hydrogen bomb is 1,000 times more dangerous than atom bomb, children. At least atom bomb and nuclear fission you can control. Nuclear fusion, once you start, you can't control, children, because these reactions are uncontrollable. And in fission reaction, you'll get alpha, beta, gamma, harmful radiations are liberated in fission. In fusion, no liberation, nothing, everything devastation. Okay, children, fusion reaction, smaller atoms combine to form bigger atom. Okay, children, let me say comparatively. I will say in comparison, what is the differences between fission and fusion? Slowly, I will say, try to understand, children. In fission, what happens means bigger atoms breaks into smaller atoms. Here, smaller atoms combine to form bigger atoms. Okay. Here, uranium is broken down with slow-moving neutron to form krypton, barium, three more neutrons. Here, hydrogens are combining to form helium. Small atoms combine to form big atom. Fission, you can control. How? By using control rods. Here, we can't control, children. We can't control. And when uranium is decomposing into krypton and barium, various radioactive elements will liberate alpha, beta, gamma. Radiations are liberated, children. Radiations are liberated. Here, no radiations are liberated, children. Direct devastation. And remember, children, fission reaction, children, fission reaction, children, can fission reactions, fission reactions you can conduct at room temperature. We can conduct at room temperature also. Fission reaction you can conduct at room temperature also. Whereas fusion reactions you cannot conduct at room temperature, children. Why? Because hydrogen is positive, hydrogen is positive. How can you join two positive atoms? You can't join them. If you have to join them, they should move with high speed. Then they can come and collide and they'll join. To move with that much speed, you have to supply initial temperature. So, fusion reactions cannot occur at room temperature. They require initial high temperatures. They require initial temperatures. They require initial high temperatures. That's why they are called thermonuclear reactions. Thermonuclear reactions. Atom bomb is based on fission. Hydrogen bomb is based on fusion. These are some of the differences between fission and fusion. Okay, fission is breaking big into small. Fusion is small to big. Uranium is broken down. Some of the nuclear fuels, what we use uranium, we can use thorium, we can use plutonium, we can use neptunium, we can use so many of them. And here in fusion, hydrogen only. And this we can control fission by people control rods. We can't control. Fusion once started over. And fission reactions, alpha, beta, and gamma radiations are liberated here. No harmful radiations are liberated at all. And here, fission reactions we can conduct at room temperature. Reaction we can start here also at room temperature. But fusion reactions to occur, initial high temperatures are required. Why? At that high temperatures, hydrogen and hydrogen positive charges will combine and liberates large amounts of energy. And that's why sun is able to liberate so much huge amounts of energy from so many millions of years all over the universe. It is because of fusion reactions only. Okay, children, that is the difference between fusion. Fusion, if you can control, you can make it as a reactor. Fission, if you can't control it, will become atom bomb. So what is happening? Bigger atom is broken down by neutron into krypton, barium, and 3 neutron. 3 will go and make 9. 9 will go and make 27. 27 will go and make 81. This type of self-sustaining reaction is called chain reaction. Means once you start self-sustaining, it will only continue. You need not to go, you neutron, you go and hit, you neutron, you go and hit. You need not to start. It will only self-sustaining chain reaction. This is called children. This type of reaction. So this is the difference between fission and fusion. And I hope children, you all know what is the difference between isotopes and isobars. You all know it. Okay, children, small discussion about isotopes, children. What are isotopes? Isotopes are the elements having same atomic number but different mass number. They are called isotopes. Hydrogen has got 3 isotopes, children. Hydrogen, deuterium, tritium. Atomic numbers are same, mass numbers are different. Chlorine 1735, chlorine 1737. Numbers are same, mass numbers are different. They are called isotopes. So many elements have so many isotopes. Children. Isotopes means elements having same atomic number but different mass number. They are called isotopes. Various isotopes are used for various purposes. Children. Okay, different isotopes. Like suppose if you take iodine is there, iodine is used in treating goiter, children, goiter. Okay, and some other elements are used in treatment of cancer. Like that, different isotopes are used in different. I was telling the heavy water is used as moderator in nuclear reactor. I was telling. Now isobars. Water isobars, elements having same mass number but different atomic number are called isobars. Okay, children, same mass number but different atomic number are called isobars. Isotones. Isotones are the elements having same number of neutrons. Elements having same number of neutrons are called isotones. Okay, children. So many examples are there. Isoelectronic series. Elements having same number of electrons are called isoelectronic series. So these are some of the fundamental terms. Isotopes are main important and their uses are very, very important. So a small revision what we discussed. First, I told about radioactive elements emit alpha, beta, and gamma radiations. Then I told about nuclear fission. In nuclear fission, big element is broken down with smaller, okay, into smaller elements. And then I told about nuclear fusion. In the smaller elements combined to form bigger. And then I told the differences. And then I told isotopes. Then I told isobars. Okay. And apart from this, the most important thing, whenever any element emit alpha particle, atomic number decreases by 2 units and mass number decreases by 4 units. Don't forget. And whenever any element emits beta particle, atomic number increases by 1 unit, mass number does not change. And when any element emits gamma particles, no change in mass number, no change in atomic number. Why do they emit alpha, beta, and gamma radiations? To attain stability. Okay, children, I hope you understood, and you will understand more better if you do so many questions on this. Thank you.